Hello everyone, October the 9th. Alright, let's get to this. Find first and last position of element in sorted array of integers sorted in non-decreasing order. Find the starting and ending position of a given target value. A target value is not found in a term -1. You must write an algorithm in O log n runtime. So target 8. So we want to find the starting and ending position of this. Well, if it's in Python, it's just going to be bisect left and bisect right. Now, if it's not, we can definitely use binary search, right? We can do binary search, but I think using the binary search provided by Java, it's probably not the easiest, because I remember in Java, it's always bisect. Oh, we can use. I just don't remember how to do binary search. It's like every time you do binary search, you have to go in here and then just search again. Now data structure. Arrays binary search. I forgot. Arrays.binary search. Collections.binary search. I think that's the one. Collections.binary search. It will return inserting position. Otherwise, if the key exists, oh, but I think it does say it simply does not. Yeah, I am not sure. If I have multiple, I think I asked this question before, right? Arrays binary search, multiple match. Nah, it's not. I forgot. Yeah, it's not guaranteed to return the first. You index one of those appearances, not necessarily the first. Yeah, so now we have to implement ourselves. So we have implement basically a binary search left and binary search right. That's what we need to do. So bisect left and bisect right. How would you design bisect left and bisect right? I think I don't remember. I think I used to do this once before. So I think it's still while, right? Low smaller than high, and then mid is low plus high divided by 2. They say you might. No, we will not get out. So I'm mid, right? So it's based on how you do this. So usually what we do is if we say nums mid, right? If it's larger than target, right? So that means too big, right? So we're gonna go to the left. So usually what we do is high or equal to mid, right? Else we say low equal to mid plus 1. So we always bias this. And when we do this, eventually, when we get out, because every time when it's too big, it stays the same, okay? It stays the same. But when it's too small or equal to, we'll go right. So if it's equal to, we'll keep go right, equal to go right. So this is equivalent to bisect right. So now we want a situation where if it's, so I think bisect left will basically say if nums mid I need to go left, okay? I need to go left. So I shall say if it's larger equal to target, then high shall equal to mid minus 1. Else low equals mid. But then the mid probably need to change because I want to bias on the high. So maybe we can do low plus high plus 1 divided by 2. I think this will bias the high. I'm not 100% sure. But we do bias high, which means every time it might go too low, right? Like, 5 divided by 2, like 2, 3, right? 2, 3 divided by 2 will be 2, so we bias towards 2. But now 2, 3 will be plus 1, so we'll bias towards the right. Well, give it a shot. I'm not 100% sure, but usually this is how I understand this. Whichever side you are biased, right? Because you have more chance of landing on that side, then you have to change that. So that's kind of how I'm going to approach this. We are going to give this a shot. It'll be very easy if you do this in Python. I mean, anyway, so well, basically just write, private int bisect left will have int. Oh, damn, it's int. That's fine. Bisect left and int target. Okay. Then we say int low equal to 0, int high equal to nums.length. That should be fine, right? And now while low smaller than high, we need to do int mid as well. So mid equal to low plus high divided by 2. We can do floor and then ceiling actually, but that's fine. Then we say if nums mid is larger than target. If it's larger than target, then high equal to mid, else low equal to mid plus 1. So we do that and then we'll return low. So that's bisect left, and then we'll do the exact same thing. But we'll change how we do the bias. So this we'll call it bisect right. Okay, everything's the same, but this is different. We'll bias to the right, and then we'll say larger equal to. This will minus 1, otherwise it'll stay the same. And then when we get out, yeah, we return this. And we say int L, we can say bisect left. Oh shoot, I think I got it wrong. I think this is bisect right. We go on the right, this is bisect left. Right, this is equal. We'll go here. All right. So when we get out, but the get out position, it's not really bicycle left, because bicycle right you can get out. Bicycle left, when you get out, is the current is larger equal to, and then we get out. So I think I should do low +1 when we get out. That's what I think. Because bicycle left is where we shall insert, right? Where we shall insert. So I can do nums target into right is bisect right nums target. Okay. Then we shall say we shall return new int two values. The first value is going to be L. Well, because it's bisect left, we can just check L directly. So L shall be less than nums.length. Okay? If it's smaller than num.length, we do something. Otherwise, it's going to be -1. Now, what is this something? That something is nums L is equal to target. If it's equal to target, then we'll return L. Otherwise, we'll return -1. So that's the first value. Second value is R. Okay, so R -1 should be larger or equal to 0 and smaller than nums.length. That means we're inside, right? We'll do this, otherwise it'll be -1. When bisect right, hey, bisect right, it is possible to. Actually, it's not possible. I don't think so. I think the only thing we need to check is to check if it's smaller than a target, right? And then we can say nums R -1 is equal to target. If it is, it'd be R -1. If not, it'd be -1. Not sure. I hope it's correct. Is this all right? Ooh. Okay. Ooh. R can be 0. So we do have to do 0 smaller equal to R -1. Unfortunately, we do have to. Alright, let's give it a shot. Ugh. So I don't think this is the right way then. Yeah, it can get too big. So if we should do this, can we still do that? Yeah, we can now because we'll how do we make changes? Let me think. Well, I guess we just try this. Hold on, +1. We set this one like that. Okay. If this can work, that will actually be very nice. Oh yeah, this is the trick. Ugh, that is not the trick. All right, so what happened? No. Expected is 0. Wait, so does L come out? That's 1, right? 0 plus 1 is 1. That's 0. Is 0 larger than target? No. So low is 0 plus 1. Bisect right. So bisect right is correct. It's bisect left. Ugh. It's still bisect left is giving me trouble. Bisect left is giving me trouble. How should I handle this? Well, in this bisect left, high is 0, right? So 0, 0, 1. So mid is 0. And so we find out is always equal to, so high shall equal to. Oh, I think I should return high plus 1. Nope. Isn't mid 0? Low is 0. High is 0. Mid is 0. Right? And num's mid is equal to the target. So high shall be mid minus 1. And when we get out, high is minus 1 plus 1. High is 0. Right? Is 0. High is 0. Which means left is 0. I do not understand why. Actually, it's a system, right? System of the print line. I just want to know what's L. L is 1. That is not what I had expected. So high is 0. How is high 0? Which means mid is 1. How is mid 1? Bum 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 bum. Bum bum bum. I could have just do the, could have just do the test. But I'm kind of lazy. Maybe we should print mid. That's for fun. Oh, we didn't even go through this. Holy crap. Maybe we should do that. Low is smaller or equal to. Oh, that is interesting. Low is smaller or equal to. We handle smaller or equal to. So when they equal, we'll do it one more time. But if they're equal, and then the mid is always biased towards the high. Maybe I set this to -1. So it's the same setup bisect right, but everything shift left for 1. That's actually a good idea. Want to see if everything else works. Think it might work. Yeah, might as well, just in case. Okay, there we go. Yeah, it's not really like trivial, because it does require some thought. "34. It is never trivial to write bisect left and bisect right from scratch. Note that bisect right is the default way of doing binary search. Whereas bisect left is a left shifted version of bisect right. I'm curious of my previous solutions, so I have a bunch from previous. Bisect left, bisect right. Oh, look at that. Binary search. Bias. Oh, I put those two at the same one. And I just say smaller or larger. And then the bias. Well, I guess you can do that. I'm not gonna read this. Do you use bisect? No, I think they are coded by themselves. Depending on how you do, I like my way of doing it. I read a post a long time ago regarding binary search. The gist is basically you find a way to do binary search that makes the most sense to you and you stick with it. So the way that makes most sense to me is do while smaller, and then you do the modification on the side that you need to get your biased against at the moment. So usually when we do this, it's biased towards the low, So it'll be a higher chance of getting low. So we need to move low instead of moving high. So that's kind of how I thought about binary search. All right, so that's that. What the hell is this? Array of objects to matrix. Write a function that converts an array of objects into a matrix M. Array is an array of objects of arrays. Is an array of objects or arrays. Each item in the array can be deeply nested with child arrays and child objects. It can also contain numbers, strings, booleans, and null values. The first row shall be the column names. The first row shall be the column names. If there is no nesting, the column names are the unique keys within the objects. If there is nesting, the column names are the respective path in the object, separated by dot. Each of the remaining rows corresponding to an object in array. Each value in the matrix corresponds to value. If a given object doesn't contain a value to the given column, the cell should contain an empty string. The columns in the matrix should be in lexicographically descending order. Jeez. Okay, so yeah, it's all right. So we have a bunch of columns. So we have to transform array into an object, into a mapping. And then the keys will be the column name. The value is just gonna be it can be a list, right? It can be a list. Oh, so we need to transform 2 times. First time transform into that, which honestly is not that bad. It's not that bad. No, it's not. Look at the second example. So for each is an array of object, of an array of array. Okay? The first row should be the column names. How do you handle child arrays? This is a child array. Oh, 0 dot. Oh, you consider an array as a like an object, right? Consider it like an object. So I still have no clue how this is going to work. If there is nesting, column name are the unique keys within the objects, respective paths. Which means if it's an array, we just keep nesting until we find the value. And all the nestings will be the key, right? And then we go for the next one. Top level, right? Top level. But what if the top level is 1 value? Not even sure if this is allowed. So hold on, here's what I'm thinking, right? I'll return a nothing because I want to test some stuff. think I want to test this one. Okay. So my question is, that's A dot B, A dot C, and A dot B, and A dot D. Oh, so every single, oh, holy crap, every single one. Damn. Every single one is so okay, so you do this, you will find the key. What if I have another one? Let's just do one more nesting. So I think it will be A dot D dot E. That should be the extra. A dot D dot E, yes. Okay, so each time you go from first row, right? You find a key and you record the value. And for the second row, oh yeah, that's fine. For the second row, you find a key and you know which row you are, so you know how many previously must has been, right? And then in the return value, ugh, I absolutely hate the return value, because the return value you just have to go row by row. I mean, it's okay, I guess. It's okay. Okay, so I think the biggest problem right now is just to figure out how to get the key. Okay, we need to get a key. So you give me something, and then you get the key. That's not necessarily. I think what is needed is given, it's basically flatten, right? You want to flatten the whole thing. So give me an object. I need to flatten the whole thing. Like if you give me this, it's already flat. That's already flat, right? That's already flat. And if you give me this, right? If you give me this is definitely not flat. So we need to flatten it. And we shall return. If you give me an object, an array, I will return an object with keys being the flattened key and the value being a value. Okay, so we can actually flatten, right? I call it object. Now, if this object itself is not an object, so if not object or instance of type of instance of is Python, I think, not equal to object, right? So it's not an object, then we just return object. All right, otherwise it is an object, then it can be an array. So we say if arrays dot is array obj, so this is an array, what you're gonna do with array. So what we're gonna do is actually we can say the return value, right? Or we can actually check so we won't have to deal with this. Yeah, I think we should check so we don't have to deal with this. So now it's that. Then, well, we need to return a flattened, right? Flattened. So for everything, so I do need to do a constant res, right? Then we need a for, let's just do int I equal to 0, int I. Let I equal to 0, I smaller than bj.length, I plus plus. Okay. Now, what we can do is if obj, if not obj, or obji or obji type of is not equal to object then we say res I, right? Res I. That's the index shall equal to obj. Done. Otherwise, it is an object. Then we need to go through flatten. So this will be a flat object, right? I should actually say else. Else we get a flat object, okay? A flat object. Then what we need to do is to go through its key and value. So we can just say for key value of object dot entries, right? We do that. Okay, so we do that. We have key and value, and then we can say res something equal to value. So this is going to be so we can say I dot k, right? That's if, and now we have an else. Else is it's an actual object. Okay, it's an actual object. Then I think we'll do exactly the same thing. You can say for I think I can just say for this in object that we go through the keys. And this shall be let key of object.keys. So now we're getting the keys out. I think it'll be fairly similar. If okay and not, I will honor the key. Otherwise, we will flatten it. Oh, already has key KK. So it will be k dot KK. And then we'll return rest. Okay, so we say const test. Yeah, this is something that is absolutely needed. Let's see. What does my function do? Flatten test. Arrays is not defined. Wait, is that array? It's not arrays. Well, this looks fine. This is exactly how it's supposed to be. Okay, so when we have that, then we can consider how we want to do this. Okay. So, array has an array of all these things. So what we need to do is const matrix map. Okay, got this. And then when you say for let I in array, I is index. Okay, I is index. Very important. Actually, no. I want I to be absolute sure that it's a integer. All right. Okay. So we get a first row. Okay, we get a first row. Now what do? We do the flatten.
Oh.
When they say let flat map. Flattened. Okay, so we can say flattened equal to flatten array I. Okay, and then what we do is JavaScript fill array. So it has to be new array, right? Oh, it just called fill. Okay. So we have the flattened. Then we need to go through its for. Oh, shouldn't we say let or const? think it should be const. Same thing, const kv of object dot entries flattened. Right? So get the key and value, and what I need to know is how many I shall put. Right? It's going to be an array of a certain size. Array of a certain size. Huh. New array len. That's what we need. So we shall say if k in mix matrix map, then this map k dot push v, done. Else map k shall equal to, actually this is at the end, k is not in the map, so we don't have to do this. It shall be new array something that fill this. So what is this? We need to know how many that has gone before. Now I is index, so I plus 1 is the total number that has gone before. So we fill it with that, and then we push this in. Okay, and just to make sure that we are on the right track, so we can call JSON to matrix. Okay, take a look. That is very unfortunate, which I don't understand why. Oh, because it's not an array. My bad. We should do that. All right, let's try again. I think this looks pretty promising. Although, I don't think this is accurate. AB is 1, 3. AC is 2. What happened to all these? I think that's sufficient. There we go. Right, this is exactly how this is. So now we just need to turn this into the matrix form. The first row is that, and then we will, yeah, it should be fine. We shall be able to do this. Come on, let's finish it strong. Keys, right? Const sorted keys equal to mix on an object keys. This map sort. It's fine. Sort based on the string. So after sort, we can call that, right? That's the, we should have a result. That's that. In fact, we can actually put sort of the keys. That's the first row, right? And then we're gonna go through row by row. And how many rows do we have? It's dependent on the array. So we should say for, let I equal to 0, I smaller than array dot length, and I plus plus, right? So that's how many we need to add to it. Now for each one, we'll go through our matrix map and we'll go through our sorted keys. So we say let key of sorted keys. You have a typo. Okay, so we do sorted keys. Then what? Then for each key, we will grab a value. We'll grab a value, right? We'll grab a value. Now we have to say if, hold a second. Rest.push. Might as well just do, let's say const roll equal to this, right? And then we shall say if this map k current I is smaller than this dot length, okay, then we say roll dot push matrix map key L, not L, that's I, okay, else we can do one line, okay, else roll dot push empty. What the hell are you doing, man? All right, so if it's inside we can do, if it's not enough I just push this. So we're blah 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 blah, done with all that, and then rest stop push roll, and then blah blah blah. Once we're done we return this. All right, let's take a look. Let's take a look. Oh, sorted, wait, hold on, I think that's a typo. I think I can purchase this very soon. I should. I've been using this for free for so long. All right, is this right? We should check the result here. A.B, A.C, A.D, ADE, 1, 2, MT5, 3, MT4, MT. Okay, I think this one looks very promising. So we are going to try. Try. Okay, let's get all of them. It's on you. All right, I think we might be onto something. Very good. Okay, very good. And I'm gonna call it for today. Yeah, I mean, it's not really hard. It's just a lot of steps. Okay, just a lot of steps in this. And the key is to flatten, right? Flatten an object. Flatten an object into into a mapping, right? With a mapping, into a mapping with a dot concatenated key with dot concatenated key and its value. So I want to remove the trick. Okay, it's called the trick. The rest is just grunt work to get the return value in the right shape. Okay. We shall look at this. Oh, it's a decent read. Dear me, how many different methods are it? 5. Gordy. 5. Yeah, this is JavaScript. The water is very, very deep in JavaScript. I think who said that? I don't remember. Someone said that. If you met someone who said he knows JavaScript, he's lying. Yeah. But I think it can apply to any language, because these things can go really deep. But anyway, I don't want to read this. I don't have any capacity to read this today, so we'll do this tomorrow. Actually, I'll do this in my free time. All right, I will end right here and see you guys tomorrow. Adios.